Alrighty again, good morning. Welcome back to MAC 1140. Today is the last day before exam 3. So remember, your test 3 is this Wednesday, which is our next class meeting, which means today we're doing some review work. Power up the devices here and we can get into it. I'd be happy to work on whatever sort of stuff you guys want to look at today. I do think it would be wise for us to do at least one or two logarithmic equations, because those have so far only been seen in that extra lecture that I posted over the weekend. In the event you haven't watched that extra lecture, we want to give you some exposure. And even if you have watched it, I want to give you the opportunity to interact. Watching a lecture online is not quite the same thing. Watching a recording online is not quite the same thing as being able to interact with the lecture. So I'd like to give you that opportunity. Let me, settings, my video settings are a little weird here. My wife is using Zoom. There we go. Oh. Okay, so what I would like you guys to do, go ahead and type into the chat if you could, while I'm getting set up here and start poking at the first few problems we're going to look at. Type into the chat anything that you want to see. It can be a problem type, could be a specific problem from the homework or from the quiz. Just let me know what you guys want to do. You want to see domains of logarithms, you want to see transformations of exponentials, you want to see exponential equation, you want to see expanding logarithms, whatever you want to see, just let me know. Again, it could be a specific problem number from any of the homeworks or quizzes, or it could just be a problem type. I'd be happy to do whatever you guys want to do. While you're doing that, I will go ahead and do the thing. This is MAC1140 section OR1, which is pre-calc, and today is the 15th of November, 2021. Today, straightforward. This is review for exam 3. Of course, the test. It's this Wednesday. Which is 11/17. Okay, so we've got one request for a domain problem. I think we're probably thinking of one of those domains of natural log problems, or logarithm in general, domain of logarithm problems, where you have to solve an inequality to sort out the domain of a log. Happy to do something like that. I will make that the first kind of requested problem type we look at. Before I do that, I just want to, like I said, kind of recap the exponential and logarithm equation stuff to make sure that those who either haven't seen the video or just didn't enjoy watching a video lecture have the opportunity to ask questions and treat that like a normal lecture a little bit. So Shauna, I will absolutely get to that, but one thing first. So a quick recap on exp and log equations. Kind of the machinery that's working underneath. So if you have a to the x equals a to the y, this can only be true if x is equal to y. And if you have the log base a of x equal to the log base a of y, this can also only be true if x is equal to y. So kind of these are the facts that make those two operations which were exponentiate take logs. Valid, right? So if you have some equation, then you can put both sides in the base A exponential. You can exponentiate. And if you have some equation involving logarithms where the outsides, you've got the log base A of something equals the log base A of something else, that's the same as having those two things being equal. So if you have some equation like, 2 to the x equals 7, you can take logs on both sides. So each of these statements can be thought of a few different ways, but really these, for us in this section, we should just think of them as sort of the justification for these two new operations. Remember, exponentiating means to put in the exponent of. And then you pick the base. And taking logarithms is what it sounds like. You put both sides inside a logarithm. And again, you choose the base. So really quick, before we jump into Shauna's problem, let's take a look at a simple exponential equation. Something like, yeah, here's a type that we haven't seen just yet. The approach is the same as all the others, but so looking down at the bottom of the page here, we want to solve the equation 5 to the x equals 4 to the x plus 1. So this is an exponential equation. My variable x is trapped in the exponent of 5 here, and the variable x as a part of this x plus 1 is trapped in the exponent of 4 here. And you may recall from our lecture on exponential equations that the procedure here is to isolate the exponential and then take logarithms. Well, here there's two exponentials and they're different bases. And they're both already isolated. One side here is just 5 to the x, so the 5 to the x is alone. The only other term present is 4 to the x plus 1, and he's alone on the right-hand side. So what would a good first step, if you're not sure, just take a guess, what would a good first step be to solve this exponential equation? Well, remember, today is your day, right? This is a review day. So if you're not sure, just take a guess. What do you think we could do here? Just throw me a guess, anything. I want to get these variables down out of the exponent.
Would you take the log of both of them?
Yeah, I'll take logs on both sides, right? This is the major operation that we use to solve exponential equations. And it's up to me what base logarithm I want to use. but I'm definitely going to take logs on both sides. I'll use the natural log because it's the only log anybody really ever wants to use. It's the nice one. So when I stick both sides inside the natural log, this is what I get. And this is the nice thing to do here because I have that property of logarithms that says a log of a power, well, that power can come down. So on the left-hand side, I get x times the natural log of 5. And on the right-hand side, I get parentheses x plus 1 times the natural log of 4. And remember, the natural log of 5, this is just some constant. The natural log of 4, this is just some constant. So this is a linear equation now. And our goal is just to solve for x. And the x is showing up in 2 places. So I'll go ahead and distribute the x plus 1 on the right. I get x times the natural log of 4 plus 1 times the natural log of 4, which is just natural log of 4. And now both this term and this term have an x in it. So if I want to solve for that x, I should pull this term over here. And then the x on the left-hand side, I can factor that out. That is common to both of these pieces. I get x times ln 5 minus ln 4 equals the natural log of 4 like this. So finally, if I divide both sides by ln 5 minus ln 4, I get my answer. And that's the exact answer. If I wanted to express this as a decimal, come on, what it? I don't know why that's glitching, but here we go. If I want to express that as a decimal, I can. I'm typing into my calculator natural log of 4 divided by, open parentheses, natural log of 5 minus natural log of 4. And I get about 6.213. Okay. So this exponential equation is slightly different than the exponential equations that I covered with you last week in that there's kind of 2 exponentials, but the basic idea is the same. You want to get your exponential pieces alone and then take logarithms, and that will give you some new equation, linear, probably, definitely not exponential, which you can then solve for x. Still taking suggestions, by the way. Let me know in chat what sort of stuff you want to see. So far, the only request is a logarithm domain problem, which I'll be doing right after this next example. For this next example, we're going to look at a logarithmic equation.
I'm sorry, can you go back to the other one really quick?
Sure.
I'm trying to do it here real quick, but it's going to be faster to ask you.
Oh, no.
Doing it when you finished it algebraically, could you do it another way? This is
Like from
probably
here?
I started going a whole other way to do that, like
What you think?
divide by x plus 1, and then you have ln 4 on one side.
So it is possible to go at this some other ways.
I mean, I'm just, I guess I'm curious if it would come out the same way.
It would. The challenge, if we divide by x or by x plus 1, the challenge then is that we're going to end up with, well, let's see what we'll end up with. So if we divided both sides by x plus 1, we would get x ln 5 over x plus 1 equals ln of 4. And I want to get the x alone. From here, we could divide by the natural log of 5. That's an option. And that would give me x over x plus 1 equals the natural log of 4 over the natural log of 5. And this is not the end of the world, but remember how you solve equations like this. You have an x upstairs and you have an x downstairs. So normally the first step to solving an equation like this would be to multiply both sides by x plus 1, bringing the x plus 1 back over here, which is sort of where we came from. So it's kind of like walking in a bit of a circle.
Okay, that's okay, thank you.
Yeah, no problem. It is possible. Another way to solve an equation like this would be to subtract this term over here and then have a common denominator. That would work, but it would again be a little bit messier. So while something like this is possible, the next step would kind of take us backwards. But you could work it from here. We would then distribute ln 4 over ln 5 across x plus 1, and then subtract the x term over here. But sort of, I think the take-home message is anytime you're trying to solve an equation for x, sort of the goal is to get all the terms that have an x on one side and all the terms that don't have an x on the other side. And I think that's much easier to do from here by first just distributing this x plus 1, because then I go, oh, this and this are the two terms that I need to focus on because they have an x. But it's not an unreasonable thought. And you know, if you stumble into something like this and you're a little bit stuck, remember on the test, you could always ask for a little bit of help. You could always ask for a hint or say, hey, I'm not sure what to do next. And then I would say, oh, well, let's try to get all the terms that have an x on one side. So maybe let's distribute this.
Thank
I have
you.
a question.
Yeah, sure.
Is it always ln and not logs?
So when solving an exponential equation, I will always use the natural log. You could use whatever base logarithm you wanted when solving an exponential equation, because what we're really relying on is this property that a log with any base of a power like this, the power can come down. So if I took the log log, the base 10 log, then the same thing would happen. These would just be log and log instead. And the whole procedure would be identical from there. Just instead of ln, it would say log.
Okay.
So with exponential equations, you can take logarithms on either side using whatever base you want. With logarithmic equations, those are a bit more sensitive to the base. So we always exponentiate using whatever the base of the log is. But here, or with any other exponential equation, you could use any base log.
Okay, thank you.
Yeah, of course. Other questions on this one? Okay. Let's take a look at one logarithmic equation before we move to the other problems. So how about the base 2 log of x plus the base 2 log of x minus 3 is equal to 2. Anybody remember how we attack something like this? This is something that we would have had to have seen in the video lecture.
You can add them together, right? What's inside the parentheses?
Something like that, yeah. So the sum of two logs here, remember we have a rule for logarithms or a log law that says if you have the base a log of something plus the base a log of something else, that can be written as a single base a log with the insides multiplied. So in order to solve any logarithmic equation, we need to isolate the log term, meaning we want to get a single log term equals a constant. So we want to put these two logs together into a single log using the blue rule. So first I would write this as log base 2 of x times x minus 3 is equal to 2. Now I've got just log of some shit equals a constant. And the procedure for solving these is to exponentiate on both sides using whatever base we have here for our log. Before I exponentiate to get rid of the log, I will distribute inside here. So this is the base 2 log of x squared minus 3x. You could do this after exponentiating. I just think it looks much nicer if you do it beforehand. So just cleaning up inside. And then here's the money step. We're going to use that new operation, exponentiate, and we're going to use the base 2 because that's the base of this logarithm. So while exponential equations don't care, you can take whatever log base you want to solve an exponential equation. Logarithmic equations like these, you have to use whatever base is given to you. So if I exponentiate here using the base 2, that means I'm going to put both sides in the power of 2, and that will give me 2 raised to the base 2 log of x squared minus 3x is equal to 2 raised to the 2. And it's important to remember we're not, this is not raising both sides to the 2. That would be like squaring both sides. I'm exponentiating both sides, base 2. So I'm putting both sides in the power of 2. And this is the nice thing to do because of what happens to the left-hand side. What is 2 raised to the power of log base 2 of x squared minus 3x? What does this all simplify to?
X squared minus 3x.
Very good. So a raised to the base a log of some shit will always just simplify to that shit. And on the right-hand side, 2 squared, that's 4. And this is now a quadratic equation. And we can solve this quadratic using the methods of section 3.1. This is the same as saying x squared minus 3x minus 4 is equal to 0. And we can factor this quadratic, hopefully. We need two numbers whose product is -4 and whose sum is -3. I think -4 and +1 work. So this is x minus 4 times x plus 1 equals 0, which means x is either 4 or x is -1. And then there's kind of a sticking point at the end here, right? I've got these two answers following this nice algebra process, but what do I need to do at the end when I'm solving a logarithmic equation?
You have to check it back.
Very good. We have to check our answers. So this very first step, where I combine the logarithms, actually kind of changes the domain. The domain of this expression right here is different from the domain of this expression right here. It's very subtle. If I plug 4 into the original equation, so let me write this down. I need to check answers. The original equation. If we check x equals 4, we get the base 2 log of 4 plus the base 2 log of 4 minus 3 is equal to 1. The base 2 log of 4, that's 2. The base 2 log of 4 minus 3, that's the base 2 log of 1, that's 0. Oh, wait, hang on. Something silly here. 4 minus 3 plus 2. So did I factor this right? X squared minus 4. No, it's not. Plus 1. Plus 4. Plus 2 over 4 is 2. Oh, I just wrote down the right-hand side wrong. Sorry, this is a 2. Okay. Yeah, the original has a 2 on the right, not a 1. Okay, good. So we get 2 plus 0 equals 2. Short moment of panic there. And this is a true statement, right? 2 plus 0 is equal to 2. So we're Gucci. If we try to check the other guy, we get the base 2 log of negative 1 plus the base 2 log of negative 1 minus 3 equals 2. So what's up here? Are there any problems with either of these pieces?
They're negative.
Yeah, this actually ties in nicely to the question Shauna wanted to see about domains of logarithms. Both of these are undefined. This is the base 2 log of negative 4, which is also undefined. So you cannot take the logarithm of a negative number, regardless of the base. Right? The domain of any logarithm is just the inside greater than 0. Right? So the base 2 log of negative 1, for example, this is not a real number. This does not exist. There is no power to which you can raise 2 to get negative 1 out. So that was our new domain red flag. So this guy is no good. This guy is fine. And this would be our only solution to that equation.
Will it ever be both?
Yeah, you could construct a problem where both answers are causing an issue in the original, and you could construct a problem where neither answer causes a problem in the original. But most of the time, these problems are most fun when there's only one extraneous solution. So it is possible that both answers you get here make the original thing undefined, and that would mean that there are no solutions to the original equation. Okay, so this reminds us of our new domain red flag, which is variables inside logarithms. And what you need, if you have a variable inside a logarithm, you need to make sure that the inside of that logarithm, whatever it is greater than 0, strictly greater than 0. So our total list of domain red flags is variables downstairs in a fraction. We need to make sure the bottom isn't 0. Variables under even roots, there you need to make sure that the inside is greater than or equal to 0. And now variables inside logarithms, where we need to make sure that the inside is strictly greater than 0. That list of domain red flags is something you need to have committed to memory. All right, let me take an example. So let's find the domain of f of x equals the natural log of about 4 minus x squared over x. So there's a few things going on here. First, I do have a logarithm with some variables inside. And then I also have a fraction with some variables downstairs. So the domain red flags here we have a variable downstairs in a fraction, and we got to remember, okay, the bottom can't be equal to 0. And we also have variables inside a logarithm. And we need to make sure then that the inside is greater than 0. So there's two things we need to make sure that we stay away from here. We need to stay away from any x values which make the downstairs 0. We also need to stay away from any x values which make the inside of this logarithm negative. The first one is very straightforward. So the bottom here is just x. So the bottom will be equal to 0 if and only if x is equal to 0. So x equals 0 is not in our domain. All right, that's coming from this guy downstairs. I know if I plug 0 into this function, even if the top is happy, the bottom has a big problem. It can't divide by 0, right? The natural log of 4, all divided by 0, that number does not exist. It can never divide by 0. The other thing we need to ensure is that the inside of my logarithm is strictly greater than 0. The inside of my logarithm is the polynomial 4 minus x squared. So I need to make sure that that is strictly greater than 0. And this being a polynomial inequality, the way we would solve it is to pull everything to one side. Factor. 4 minus x squared factors as 2 minus x times 2 plus x. And then record our cut points on a number line. from this factor, I get +2 as a cut point. And from this factor, I get -2 as a cut point. So here's my number line. I could use the end behavior of this polynomial together with the multiplicity trick to fill out the signs here. The end behavior of 4 minus x squared is down on both sides. So that tells me that we're going to be negative over here and negative over here. And then by the multiplicity trick, we will change sign as we hop from region to region. Or I could test some points. If you test x equals -3 here, you get 4 minus -3 squared, which is 4 minus 9, which is -5, which is less than 0, negative. If you test x equals 1 in here, you get 4 minus 1 squared, which is 4 minus 1, which is 3, which is greater than 0. So we're positive in here. And if you were to test x equals 3 over here, you get 4 minus 3 squared, which is 4 minus 9, which is -5, which is less than 0. So whether you get there using end behavior and the multiplicity trick or by test points, you still get this sign array. So what is the solution to 4 minus x squared is greater than 0? What numbers x make the inside of that logarithm positive?
Is it -2 to 2?
Yeah, it's this stuff, right? This is where 4 minus x squared is positive. So the solution to the inside of my log is greater than 0 is the interval. It's the open interval from -2 to 2. Right, -2 and 2 themselves would make this exactly equal to 0, and I want this thing strictly greater than 0. So I don't worry about the endpoints because it's a strictly greater than, not a greater than or equal to. So what's my domain? I know that x equals 0 is not in my domain. And I know that the inside of that logarithm is positive just between -2 and 2. I need both of these things to be happy. So here's the open interval from -2 to 2. But then I get here to 0, and 0 is not in my domain because 0 makes the bottom 0. So this is my domain. -2 to 0, union with 0 to 2, all open. And this is about as complicated as a question I could ask you about domains on this test. You've got multiple domain red flags, one of them coming from this logarithm stuff. The one coming from the logarithm here requires you to solve a polynomial inequality. This is fairly sophisticated stuff. You have to remember not only the new domain rules, but also how to solve inequalities like these, which is something from the previous section, and the old domain. Any questions about this guy? Okay. I think it wouldn't hurt to look at just one or two more problems. Say hi. It wouldn't hurt to look at one or two more problems where we're solving some exponential and logarithmic equations, since that's the most recent stuff we've been talking about. And maybe some simpler ones. So I'd like to get just a little bit more interaction here than we did on those last few ones. I want you guys to feel comfy with these, because I 100% promise you there will be a problem on the test that is just straight up solve this exponential equation. And there will be a problem on the test that just straight up says solve this logarithmic equation. So to that end, let's look at a couple, maybe even simpler equations here. Let's solve about, yeah, sure. 3 to the x over 14 equals 1 over 10. And again, something kind of straightforward. 2 minus the ln of 3 plus x equals 5. So let's start here. What can I do here? Part A.
Take the log of both sides.
Yeah. Yeah, here's my exponential term. It's already isolated, right? My variable is stuck inside this power, but there's no constant multiplying this. There's nothing being added or subtracted to the exponential. So my first step right here would be to take logs. And again, I'm going to use the natural log, but you could use whatever base logarithm you want. The reason we take logs is because the way logarithms and powers interact. This quantity here, which is in the power, can come down in front. So this will become, oh, sorry, x over 14 times the natural log of 3 is equal to the natural log of 1/10. So now I've gone from an equation where the x's are stuck in a power to an equation where the x's are just chilling. They've got a, there's a constant multiplying here and a constant dividing here, but this variable x is no longer in a power. What could I do to proceed from here?
Move the ln of 3 over.
And how do I do that? What's the operation I would use to move this guy over here? Nice. Subtract it over, multiply it over, divide it over, something else.
Divide.
Yeah, right now it's multiplying my variable, so I need to divide that natural log of 3 over. And that'll leave me with x over 14 on the left is equal to the natural log of 1/10 divided by the natural log of 3. Okay, what now? what's keeping me from having x alone here? That's just this 14, right? If not for this 14 over here, I would have x equals some shit. So I want to multiply both sides by 14. And that's it. That's the problem solved. Try to launch Wabbit again and see if it'll boot up so we can get our decimal. There we go, worked this time. So I take 14 times natural log of 1/10. And then I divide that by the natural log of 3. I get negative 29.343-ish. And we could always check. If you want to check if your answer is reasonable, you could take 3 and raise it to the power of parentheses. This is negative, wasn't it? Sorry, negative of negative 29.343 divided by 14 and see what we get. This should come out close to 1/10 or 0.1. Oh, good, 0.09999999. So that is very, very close to 0.1. Or sorry, yeah, 0.1, very, very close to 0.1. So this approximate answer, when plugged in here, gives us something very, very close to 1/10, which is 0.1. All right, let's try part B. What would I do to solve this guy? I need to get the natural log term by itself, right? I need to isolate the log term and then exponentiate. So what's keeping this log term from being isolated at the moment?
The 2 minus.
Yeah, the 2 and the negative. So first, let's get rid of the 2. If I subtract 2 from both sides, I get negative ln 3 plus x equals 5 minus 2, which is 3. Before I can get rid of this logarithm, I need to get it alone. Right now, there's a negative out front, so I can get rid of that negative by rewriting this as the ln of 3 plus x equals negative 3. So now we have isolated the log term. What do I do now to get rid of the ln here? What's kind of the other version of this take logs operation? We take logs to get rid of exponentials. We do what to get rid of logs?
Shouldn't you multiply by e on both sides and make the right side e with -3 as the exponent?
Yes, almost. So I think what you said is for the result is correct, but the terminology we need to be a little bit careful. We're not multiplying on by e on both sides. We're exponentiating base e. So the base of this logarithm, it's the natural logarithm, is e. So if I want to get rid of that logarithm, I put both sides in the exponent of e. It's true that what we get on the right-hand side is e to the -3. And on the left-hand side, when I simplify e raised to the ln of 3 plus x, I just get 3 plus x. So we have 3 plus x is equal to e to the -3. And from here, life is easy. We just subtract the 3. So I get x is equal to e to the -3 minus 3. And that's our guy. So log and exponential equations, they're not that bad. They really aren't. But you do need to be comfortable with those two operations. Take logs, which is what we do to get rid of exponentials, and exponentiate, which is what we do to get rid of logs. Some people like to jump straight from this line to this line, and I'm okay with that. Right? I don't have a problem with you going straight from ln of 3 plus x equals -3 to 3 plus x equals e to the -3. But this sort of in-between step here, this is the reason, this is the why. So I think it's worthwhile, if you want to understand what's going on, going from here through here to here. The reason we exponentiate to get rid of a log is because exponentials are the inverses of logs. And the reason we take logs to get rid of exponentials is because logs are the inverses of exponentials. Remember, that's how we started talking about this stuff. To that end, I'd like to solve one more problem before I let you go. And this kind of like the domain problems tie back to something we were doing before. Inverse functions. So let's say, let's find the inverse to the function 2e to the 3x. When we go through the normal inverse finding process for this guy, we're going to have to solve an exponential equation. So remember, to find inverses, first you write y in place of f of x. So I'd have y equals 2e to the 3x. Then you try to solve this for x. So if I'm going to solve this equation for x, I'll just write it down. What I'm really trying to do is solve an exponential equation. I'm trying to solve for this variable, which is stuck in the exponent here. So I could divide both sides by 2. then take log, so I would take the natural log on both sides. The right-hand side, the ln of 3x, or e to the 3x, just becomes 3x. And then if I divide both sides by 3, or multiply both sides by 1/3, I get 1/3 ln y over 2 is equal to x. Nope. So now I've solved for x. I would swap x and y. So I would have 1/3 natural log, oops, sorry, swap x and y. 1/3 natural log x over 2 equals y. So finally, this guy is my inverse function. Maximum. No puppy. So
I noticed in the homework, I think I got marked wrong on one when I put the answer as that ln to the y over 2. I don't remember which problem. It was just divided by 3, but instead you put the 1/3 on the outside. Is that the proper way to write it?
either one would be okay. You could also write this as ln of x over 2 all divided by 3, but not ln of x over 2 all divided by 3. So you do have to be careful. If you're going to divide a natural log or any log by some number, make sure that you're using these parentheses to show what's inside the log and what's outside the log. If you don't use those parentheses, it could be ambiguous, right? So if you write just ln x over 2 over 3, like this, I don't know if this divide by 3 is outside the log or inside the log. So
Okay.
this would be incorrect, but this would be just fine. All right. Other questions on this one? Other problems you guys would like to see? Okay, then we are a few minutes early, but if you guys are happy, then I am happy. This test is going to be on Wednesday. If you want to take it at the testing center, remember you don't need to make any specific reservations. I will make a blanket reservation for this class to walk into the testing center on Northwest Campus and take the test anytime during the day on Wednesday. If you want to take the test online with me, remember you need to sign into Zoom on your phone. Come to that Zoom meeting, get your camera set up so I can see your desk, your hands, your paper, all that good stuff. And then once you get the okay from me, you can launch the test in Canvas. One little thought, and that is that if you want to have the ability to ask questions during the test, then you have to take the test online with me, obviously. The proctors at the testing center are neither capable nor willing to answer questions during the test. And this is a big deal to some people. So anytime I'm proctoring a test in a classroom, if somebody raises their hand, I'll walk over and ask them what's up, and I'll answer a question as thoroughly as I can without kind of violating my ethics. So if you're just forgetting a symbol, or you're forgetting a bit of notation or a formula or something like that, I don't have a problem giving you a little hint. So if you think you may benefit from that, then I strongly encourage you to take the test online with me. But of course, you're welcome to take the test at the testing center. Either one is totally fine. And that's it. So the test is Wednesday. Make sure you catch up on the homework if you have not yet. I went out and cleared extensions over the weekend. I will check them again today before my office hours. There is a quiz and the 2 homeworks from section 4.5, both of which are due on Wednesday, on the day of the test. And if there's any older homework that you need to work on, please go ahead and submit an extension request so I can grant that. You can get in there and practice those things. If you're having problems with any of this stuff, please come by my office hour. I'd be happy to sit and solve some problems with you, talk through your work, whatever you want to do. I want you guys to feel comfortable on this test. But that is it from me. I will see you on Wednesday. Oh yeah, go ahead.
Really quickly, I can't make it to your office hours today. Can I email you to set up a time for later this afternoon, like after 5, if you are available?
Maybe. So my wife has a class in the evenings, and I'm on baby duty. But if you cannot make it to the office hour, definitely send me an email, and we can try to set something up for later in the day. Worst case scenario, I'll ask you to email me a picture of your work, and I can like write out a response with when my hands are free and send it back. But yeah,
Okay.
we can certainly try. Alrighty. Anything else, guys? Okay, then that's it for me. Please work hard. Make sure you're prepared for this test. We want it to go well. I will see you guys on Wednesday. Take care.